Well, hi everyone. We've got this video here on rationalizing denominators, and I just have a little statement that most conventions, the way it's accepted for simplifying anything with radical expressions, will require that the denominator not have a radical. So to not have a radical, go from this is irrational, we will rationalize it, and then there will be no more radical in the bottom. So there's two kinds of problems here. The ones with single term denominators, and that's 17. And then there's ones with two-term denominators, or binomial kind of things going on there. So the single-term denominators, the real problem here is the square root of 17. And how can I get rid of the square root of 17? How can I get rid of the square root? And the real way of doing that is multiplying by the square root of 17 again. And when I multiply by the square root of 17 on the denominator, I have to do it to the numerator. So I'm not changing the value of this whole thing, because square root of 17 over square root of 17 is 1. But what I am doing, and let's deal with the denominator, 4 times the square root of 17 times the square root of 17, that is 4 times the square root of 17 squared. And the square root and square, those are inverse operations. So that is going to, and I'll just continue working with the denominator here for a second. The square root of 17 squared is 17. All right, well, where do we go from there? We'll distribute the denominator. I got the square root of 5 times the square root of 17 plus 4 times the square root of 17. This top part here is square root of 5 times square root of 17 is the square root of 85 when you multiply those together. And then I've got the real part, not real part, I have the integer part and the irrational part there. And to finish up, I'm going to take this numerator, square root of 85 plus 4 radical 17, and in my denominator I'm taking 4 times 17, and that is 68. And that is equivalent to where we started, but notice the denominator does not have a radical in it. We have rationalized the denominator. The denominator is a rational number instead of an irrational number. All right, now when you have two-term denominators, you need to multiply the top and bottom by the conjugate of the denominator, and that will allow you to rationalize the denominator. So change the minus here to plus, and you have got the conjugate then. And when you multiply the bottom, you got to do the same to the top. Okay? Now I'm going to FOIL the top. First, 3 radical 3 outside, 3 times 1 plus 3 inside. Square root of 3 times the square root of 3 is 3. And last, square root of 3 times 1 is the square root of 3. I'll simplify that here in a second. Now I'm going to do the same. I'm going to FOIL in the denominator. First, square root of 3 times square root of 3 is 3. Outside, square root of 3 times 1 is square root of 3. Inside, negative 1 times the square root of 3 is negative square root of 3. And last, negative 1 times positive 1 is negative 1. It is time now to simplify. And I have 3 radical 3 plus 1 radical 3 here. Okay? Those are you can treat them like terms, which you do with variables. 3 radical 3 and 1 radical 3 is 4 radical 3, and 3 plus 3 is 6. And here, the positive radical 3 and the negative radical 3 cancel out, and that's why the conjugate always works when you're trying to rationalize the denominator. And 3 minus 1 is 2. I'm going to do one more thing. I'm going to factor a 2 out of both these terms so it'll cancel with this bottom to make it a little simpler. So 2 times 2 radical 3 plus 3. 2 times 3 is 6. So if I factor that and then put that 2 down here and cancel those out, I've got 2 radical 3 plus 3. All right, I have one more example to look at. I haven't seen where this will lead, so let's see what we can do here. The conjugate is the square root of a minus the square root of b, the conjugate of this denominator. So let's multiply the numerator by the square root of a minus the square root of b as well. All right, I'm going to put the parentheses in FOIL. First, a radical a outside minus a radical b inside. Negative b times, so I'm going to make negative b radical a. These are not the same. You can't just switch those around. And then last, negative times negative is positive b radical b. All right. And then outside, square root of a times square root of a is a. Inside, that's first, sorry. First, outside is negative, and it's radical a times b. Inside is positive radical b times a, or commutative property says I can switch those around. And then square root of b times negative square root of b, that's minus b. All right, now when I go to simplify, these two are considered like terms. I'm going to write them beside each other first. Let me just rearrange things in the numerator first. A radical a minus b radical a minus a radical b plus b radical b. And then in the denominator, these are opposites. They cancel out. So a minus b. Notice how nice it is there. We have eliminated all the radicals there. So we've rationalized the denominator. I want to play around with this numerator a little bit. These each have that square root of a. So if I take a minus b, that's what's in front of the square root of a there. Think if you went to the distributive property here, you would have this, right? Well, we're kind of doing it in reverse. And then on this one, if I were to write the square root of b, I would have, let me write plus, and then negative a plus b times the square root of b. I did write the plus because I'm treating this kind of as a plus negative a right now for the time being. And that is over a minus b. Now this is almost perfect for canceling, except this is not the same, but it is the opposite. So I'm going to rewrite this. The first part I'm leaving is a minus b as a factor, radical a. Second part, I'm going to write minus where plus was. And if I change this sign, it will be a, and if I change this sign, it will be minus b. Do you see how minus a is negative a, and minus minus b is positive b? That lets me have that a minus b there, and I still have the radical b there. and that's over a minus b. So what actually happens now is we could do these separately, but these a minus b's are all going to cancel. So I'm trying to think of a way that's not super confusing, but let me see if this works for you. I have a minus b here and I have a minus b here. Those are common. Here's what I'm going to do. I'm going to separate those into two parts. A minus b times the square root of a over a minus b, that denominator, minus a minus b square root of b over a minus b. These a minus b's are going to cancel. So that's the square root of a. And these a minus b's are going to cancel, and that's minus the square root of b. This is the best, most simplest answer, because that does cancel. Now, the other option, maybe I'll show you in class. We'll talk about that in class. We've gone long enough on this video. So I will have more of these practicing things to do, and we will have fun with these in class. Take care now. Bye.